When we read a word problem that we will need to solve, we look for certain keywords that tell us whether we're dealing with an inequality or an equation. In this case, words like more than alert us to the fact that we're dealing with an inequality. So let's read the whole story. It talks about the Onalaska Hilltoppers and the fact that they have won 48 of the 72 total games so far. The question, how many of the remaining games need to be won in order to have more than a 70% winning season? Our next step after reading carefully would be to define the variable. In this case, we're going to use the variable x, and from our question mark, reading backwards, we notice the question is how many of the remaining games. So it would seem natural to define x to be the number of remaining games. Finally, we will reread one more time so that we can create a plan which we can then solve. Rereading, the total number of games they'll have won by the end of the season is 3/4 of that 48 out of 72. That is what they've accomplished so far. So talking about 3/4 of the 48 and the unknown will need to be more than, that would be greater than, 70%, which I'll now write as a decimal, of all their season games. And here they told us that our total season games 72. Now, with this inequality relationship, we need to look at the best way to solve that. In this case, before distributing, I would prefer to simply multiply by the reciprocal. This actually involves less arithmetic because these will divide, leaving 48 plus x to be greater than, doing the arithmetic on the right side, we're going to have 67.2. That leaves me with a subtraction of 48, and x must be greater than 19.2. Now, anyone familiar with athletics realizes that you don't win part of a game. So the common sense in word problems would indicate that we'll have to actually win more than 20 games to have a season where we win 70% at least of all games played.